In this lesson, we are going to be looking at systems of equations. That means more than one equation at a time. And we are going to have two equations with two different variables, and we are going to need to solve them. So this is just, you've seen this before, where it will say something like solve this equation, and it tells you that x is 3. Okay, so here's value that it gives you. It gives you x is 3. What you do is you use that information and you plug it into the opposite equation. You've done this. So it will say something like solve this equation right here, knowing that x equals 3. Well, what you're really doing is taking x out of this equation and replacing it or substituting it with the value 3. And then you would go 2 times 3 is 6 plus 6, and y would give you 12. You are doing substitution when you do that, you just didn't know it. Okay? Of course, we need to move on to some more complicated methods. So here are two different linear equations, and I know they're linear because they have no more than two variables. There are no exponents or square root symbols. Your variables are not in the denominator, and your variables are not being multiplied by each other. So you can see that each of these equations is linear. Okay? When you have more than one linear equation at a time, or even nonlinear equation at a time, but more than one equation at a time, it is said that you have systems of equations. So when you have more than one, you have systems. So I've got the blue equation, y equals 2x minus 3, and the red one, x plus 3y equals 5. So I've got a system of equations. Okay? What we want to do is we want to use those equations, and we want to get a value for both x and y. We have two variables, but luckily we have two equations. So we will learn our first method to do that in this lesson, which is to solve it by substitution. To do that, what you want to do is you want to take one equation, either one, it doesn't matter which one, just one of them, and you need to get either x or y by itself. So in this particular example, my top equation is already solved for y, so I've got it by itself. Then what I'm going to do is I am going to circle that equation. Okay? And do you see how the top one is solved for y? It says y equals. Well, those two sides of that equation are equal to each other. So y has the same value as 2x minus 3. So what I will do is I will go to the opposite equation, and since this is solved for y right here, I am going to take that 2x minus 3 into my opposite equation, and I am going to replace the y with 2x minus 3. Y has the same value as 2x minus 3, so I can replace the y with 2x minus 3. Okay? When I do that, it looks like this. Now I'm using this equation right here, and I'm replacing the y. So instead of y, I'm going to write the quantity 2x minus 3. Make sure you put it in parentheses because that 3 that's out in front does need to be distributed. So then I will have x plus 3 times 2x is 6x. 3 times negative 3 is negative 9 equals 5. If I combine my like terms, I'll have 7x minus 9 equals 5. Then I will add 9 to both sides. And I will have 7x equals 14. Divide by 7. And I will have x equals 2. Okay, now, you are not done. You have two different variables you're working with here. You see x's and you see y's in both of these equations. So you are only partially done. I now know my value for x, but I need to know my value for y. And what you do to get that is you take that x, in this case, it's not always x, but you take the x and you plug it right back in to where you circled it. And actually, you could plug it into either equation, it would not matter. But it's easiest if you plug it right back into where you circled. And so then I will have, in that blue equation now, I am going to say y equals 2 times, instead of this x right here, I now know that x is 2, so I will replace it with 2 minus 3. And then I'll have y equals 4 minus 3, or y equals negative 1. Okay, now, when you give me your grand final answer when you do these, your answer should actually be written as a coordinate. So your answer should be an x, comma, y coordinate every single time. So in this case, my x value was 2, and my y value was -1. And this actually is your grand final answer that is the solution to this system. Now, you didn't know what you were doing, but what you are really doing when you are solving systems is I have given you two linear equations, y equals 2x minus 3 and x plus 3y equals 5. I have graphed them both here on this graph right here. And if you notice, the point 2, well, oops, this should be +1, by the way. Oh my goodness, I caught myself there. This should be y equals 1, not -1. Okay, anyway, sorry. What you really did when you figured out the point 2,1, if you look at the graph, here's the point 2,1. And what you have figured out is where those lines intersect. So in this case, this system of linear equations that I gave you had one solution, which means those two lines intersect in one point, and the point that they intersect at is 2, 1. All right, following those same steps now, we want to get either equation solved for either x or y. In this case, they both happen to be solved for x, so it doesn't really matter which way you go, but you're going to get one equation solved for either x or y. I am actually going to take this one this time, and it really does not matter. But I have that equation solved for x equals. So that means wherever I see an x, I can replace it with 2y minus 7, since there's that equal sign in between and they have the same value. So I'm going to go to the opposite equation, and where I see an x, I will replace it with 2y minus 7. So I'm using the blue equation right now, and I'm going to replace the x, this x right here, with 2y minus 7, and then equals the other side, 3y plus 2. Now you notice that I only have one variable in this equation. It's only y's. I only have y's. So now I can solve for y, which is good. So I will subtract 2y, and I will get -7 equals y plus 2. And then I will add 2, or subtract 2, I mean, and y equals -9. Okay, so there's my first variable that I've solved for. So I now know what y is, but I do not know what x is. So I will take that and I will put it right back in where I circled. And then I'm going to take the x equation and I will say x equals 2 times, instead of y, I can replace that with -9 minus 7. So x equals -18 minus 7, or x equals -25. Okay, still not your grand final answer, because again, your grand final answer needs to be written as an xy coordinate. X needs to come first, and then y. So this is actually how I want your answer. Again, what you have just figured out is I have given you two lines. I could get them in y equals mx plus b form if I wanted to, but I've given you two lines and I've figured out their solution, which means where do they intersect. And in this case, they intersect at the point -25, -9. All right, here's another one. In this particular case, neither one of these equations are solved for either x or y. It does not matter. You could get the top equation solved for either x or y. You could get the bottom equation solved for either x or y. It does not matter, but one equation needs to be solved for either x or y. I'm actually going to take the bottom one, and I am going to add 2y to both sides, so that this equation now says x equals 2y plus 3. Excuse me. Now I've got that equation solved for x, which is good. And so I will circle it, and I will go to the opposite equation. And wherever I see an x, I can replace it with 2y plus 3. So I'll go to the opposite equation. Where I see an x, right there, I can replace that x with 2y plus 3. And so I will have 2 times 2y plus 3 minus y equals 2. Distribute that through. So 4y plus 6 minus y equals 2. If I combine my like terms, 3y plus 6 equals 2. Subtract the 6. 3y equals negative 4. Divide by 3. And y equals negative 4/3. Okay, I know you might freak out because you get fractions once in a while, but it's going to happen. We didn't do this wrong. We just got a fraction for an answer. Okay, then now I've got my y value solved, but remember each of my equations had two variables in them, an x and a y, so I still need to figure out what x is. So I will take that y, I will replace it right where I circled, and I will use that red equation now. X equals 2 times y, which we already know is negative 4/3, plus 3. Okay, remember that this is 2 over 1, and when we multiply fractions, we just multiply across the top and multiply across the bottom. So I will have negative 8/3 plus 3, and that 3 that's on the end is 3 over 1. And so I need to get common denominators and make that be 9/3. So x is negative 8/3 plus 9/3, which gives me 1/3. Okay, again, I do want your grand final answer as a coordinate that goes x value, comma y value. So this actually should be what my final answer looks like. And again, what that means is that those two lines intersect at the point 1/3 and negative 4/3. All right, let's see, on this particular one, again, I want one equation solved for either x or y. So I've got that happening in this case. I've got the bottom equation already solved for y, so I will circle it, and I will go to the opposite equation. Wherever I see a y, since that's what this is solved for, I will plug it in to replace that y with 3x plus 2. So I'm going to the blue equation now, and I have 6x minus 2 times 3x plus 2 equals negative 4. Notice that now your equation only has one variable in it, it's x's. If you've done this and you've got more than one variable in there, then you won't be able to solve it and you have done something wrong, okay? So distribute this negative 2 through, so I have 6x, negative 2 times 3x is negative 6x, negative 2 times 2 is negative 4, equals 4. My 6x's will drop, and I have negative 4 equals negative 4. Okay, we've talked about these situations before, but here's the deal. When all of your variables or your letters, in this case my x's, drop out, you're left with two choices, either no solution or all real numbers. Okay, no solution will happen when what you're left with does not equal each other. But in this case, all of my variables or my letters dropped out, and what I was left with is a true statement. Negative 4 does equal negative 4. Because that's a true statement, my answer would be all real numbers or infinite solutions. I'm going to just write this because this is going to come back in a few days here. So your actual answer would be all real numbers, which means there are infinitely many solutions. And you didn't know this coming off the top here, but really and truly, if I were to get both of these equations up here, both the blue one and the red one right here, both into y equals mx plus b form, both equations would be y equals 3x plus 2, which means that we actually have the same exact line lying on top of each other. So the computer program I used to create it, you can't see it, but the line that's right here, this red line, is the equation y equals 3x plus 2. The blue line would end up actually lying right on top of it because they are the exact same line. And when they are the exact same line, they intersect in every single spot possible, which is why your answers are all real numbers or infinite solutions. If this happened, okay, let's say this was a different problem, and I had something like this. 6x minus 6x plus 3 equals 4, let's say. And that dropped out, and what I was left with was 3 equals 4. This is not a true statement. 3 never equals 4. When that happens, your answer would be no solution. And what that means about the two lines that you're given, if the two lines never intersect, so if I have this line right here, and it never intersects with another line, what that means is that the lines have to be parallel. Okay, so I am going to even write this so that we know. Okay, up here, your answer would be all real numbers, which means there's infinite solutions, which really means they are the same line. Okay, and that's it for this lesson.